All right. I split the counting principle into 2 days because there are some words that you've heard before. I know permutations and combinations and all that good stuff. But combinations can be very confusing, especially when they turn to circular. And so that's why I split it into 2 days. But the fundamental counting principle is really just, if I have one event, it can happen a certain number of ways, and then there's another event that can happen a certain number of ways. What's the number of ways that those two can occur in sequence? And that's probably some of the most important. How can the two events occur in sequence? How many ways? Those are probably some of the more important ones. And all you have to do is take m times n. Okay. A lot of you would probably remember this, at least the way I taught it, is basically the blanks, right? Put the blanks and then put how many options you have for each blank and do what with them when you're done? Multiply, right? Okay, so that's kind of how we've done that in my classes in the past, when we've had this in other classes. So you're going to purchase a new car. There's different manufacturers, sizes, and colors. And how many different ways can you select one manufacturer, one car size, and one color? So in other words, how many options do you have for that car? Okay. And so how many blanks would we have based on how this has been taught before? 3 blanks, because we have manufacturer, car size, and color. So in that first blank, how many options do you have? 3. Have any of them been eliminated, like saying you can't do Ford or can't do any of them? No, I said any of the 3, right? So there are 3 options. In the second one, you're either going to get small or medium. So there are, and I haven't eliminated any, so 2. And then the last one, we have 1, 2, 3, 4, because we have white, red, black, and green. So we have 4. So does that mean 324? No, because you have to multiply it. So 3 times 2, 6, times 4 is 24 different combinations, correct? Okay. Probably seems like a rather high number, but there are 24 different combinations that you could put together this manufacturer, car size, and color. Any questions on that one? Okay. It helps to have had this in other classes before. So a permutation is an ordered arrangement of objects. Ordered arrangement. The number of different permutations of n objects is a lot of times just called n factorial. And that's if I just have a certain number of objects. And that's basically considering that I'm taking all of them and ordering them. So a good example here is the starting lineup for a baseball team consists of 9 players. So if you just take those 9 players that we know have to play, how many different batting orders are possible? Now we could do the blanks, right? Or we could use this rule up here. I'll show you that it's the same. If we use the blanks, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9 blanks, correct? How many possible people can I lead off with? 9. Okay, now somebody is in that spot. Can you bat in 2 different spots in a batting order? No. So how many people are left for the second spot? 8, and then you get the idea, right? Because I am taking all of them, right? Taking all 9 of them. And so, okay, you could do that, right? We could sit there and multiply it out, but it is known as 9 factorial. So depending on what calculator you have, it's probably under a probability button somewhere, the little exclamation point. And what that really means is take 9 times 8 and all the way down to 1. Okay? This is going to be a little bit larger number than you're anticipating. Okay? Has everyone been able to find a factorial button on their calculator? Okay? If not, because I don't know if they are on the phones and the iPads. Is it on there? Like you have to turn it sideways or something, or is it just on there? Okay. So make sure that you know where it is. And we'll take a second here to make sure everybody can find it. Okay. Were you surprised by the number? Because what did you get? I heard 362,880. So that's just with 9 players, and assume that most teams have more than 9 people, right? So then it makes things interesting. So that's just taking your 9 starters and jumbling them up. You can jumble them up that many ways. But realize what that means is, let's say one of you is batting here and then another one of you is batting here. If I just flip-flop those, do you agree that's a different order? So that counts as, that's 2 already, and we just switched 2 spots. So do you see how this could add up rather quickly? Okay? So again, probably one of the key words is, or the key words, ordered arrangement. And in this case, I was taking all of them. In some cases, you don't take all of them. You have lots of objects, but you want to know how many ways can I pick just 3 of them? Or how many ways can I arrange just 5 of them instead of maybe all 9? So a number of permutations of n objects if I'm only going to consider r of them. Okay? And that n and r may look familiar. And those of you on your calculators, when you found factorial, you may have found some other things that looked rather familiar. Okay? And that is the NPR. It's n objects permutated r at a time, otherwise known as NPR. And this is a fairly simple formula because there is basically what we had before, n factorial, right? That's if I took them all, right? And what we're going to divide by is basically we know we're not going to take them all, and so we won't actually have 9 times 8 times 7 all the way down. Maybe I'm only going to take 3 of them. Okay, so then some of it's going to cancel out, and I'm going to show you on this next example how that actually works to cancel out the ones I don't want. Okay, what that division right there does actually makes the overall number smaller. You agree with that? If I divide by something, it's going to make the overall number here smaller, because I'm going to divide by something bigger than 1. So here we go. We got 43 cars that are started the 1998 Daytona 500. That's actually true, by the way. How many ways can cars finish first, second, and third? We're assuming no ties. All right? So we could do it basically 2 different ways. One of the ways is to follow this. Okay, so how many cars are there? Well, 43 factorial divided by, so n in this case is 43, right? So it's 43 minus, well, how many of the cars am I really concerned with? Just 3, right? I'm just taking 3 of them, right? Because they're going to finish first, second, third, right? And so we're going to do 43 minus 3. So in other words, what's really going to be on the bottom? 40. You see it's parentheses, so you have to do that first, right? And then factor, so 40 factorial. So what that really means is take 43 times 42 times 41 times, whoa, that's a really good 41. 41 times 40, and what am I doing? And then ellipsis, right? Keep going all the way down. And the bottom is 40 times 39, and once again, ellipsis, correct? Now I could write them all out, but I think you see how this is going to work, right? Because if I take this times 40 times 39 on the numerator, this is all going to cancel with the bottom, correct? So do you see I'm really just left with 43 times 42 times 41. Could we kind of have gone back to our blank method? Said here's first place, second place, third place. How many options do we have for first place? So any of the 43, right? And now if you finish first, you're not also going to finish second. Okay, so there's only 42 left there, and then only 41. So would this formula that we're looking at now, would it have worked for that last example? Okay, well let's figure out the answer first. What do we got for this one? I'm sorry. 74,046. Again, why is that number so large? Because I could take car number 1, that could finish first, and then I could say, oh, it finished the second. Then see, there's lots of them I can jumble around, right? Because the order is important, right? Switching first and second place makes a difference, right? So now, does it work? Does that formula work for this example? Oh, is there a question or? The question was, does permutation have to do with order? Let's put it this way, if you switch things around, it's counted as a different option. Okay, so if I put somebody in first place and somebody in second place, okay, and then I switch them around, that counts as a different order. Are they the same people? Yes, but are they arranged differently? They are, so that counts as a different option. Okay, good question. when we talk about combinations, that would still be the same group of people, so it wouldn't matter to us. Okay. So let's go back to this one then. Does the formula work here? Because it's N, P, R, and R, and this one is, how many of them am I taking? I'm taking all 9, correct? Let's see how this formula works. So it's really 9 factorial over 9 minus 9 factorial. Yeah, here's the kicker. 0 factorial is 1. Okay? You can type that into your calculator if you want. 0 factorial is 1. So really it ends up being 9 factorial over 1, and doesn't it end up being this then? It is. Okay, so it works. Okay? So the formula works here as well. Okay, distinguishable permutations. So any questions so far? I'm going fast because I know most of you have seen this before. Okay. This is where you have like the repeats, kind of when we had the letters before and you couldn't tell the difference between the letters. How would you figure out how many were distinguishable? And that's an easy way to do it is with words, like if they're typed. Okay. The number of arrangements that are noticeably different. So again, that's like me before. If I switch somebody in first and second spot, but let's say they're twins and I can't tell the difference, would it be noticeable to me that it was a different option? Not really, not if they're twins. Okay. Identical twins. And this formula is a little scary when you see it, but actually once you see it in action, it is quite simple. So here we go. Saying take n factorial, however many options you have, and basically you're saying, for example, if it's a batting order, 9 times 8 times 7 times 6, right? That's 9 factorial. Now in a batting order, if I had identical twins and I switched them around, we would probably be able to tell because they have a number on their back, correct? But what if they didn't? They were just wearing the exact same outfit. Would I really be able to tell that they switched spots? No, so would that count as a different option if I can't tell? No, you can't count that as a different option. So what you put here is if something repeated, you put how many times it repeated, and then factorial. What if something else repeated? You put that there, and how many times it repeated, factorial. And then you keep going until you've exhausted all of the things that have repeated. And you will divide by it. Okay. Another good example for this is a subdivision. I don't know how many of you have ever gone through a subdivision of a major U.S. city, but it seems like every house looks exactly the same. Okay. And they're all painted the same. You just hope that you know the house number so that you can find it. So a building contractor is planning to develop a subdivision. The subdivision is to consist of 6 one-story houses, 4 two-story, and 2 split level. So what they're saying is all 6 of those one-story houses are going to look exactly the same. Okay? The two-story houses, all 4 of them will look exactly the same. And the split level, all 2 of them will look the same. How many distinguishable ways can the houses be arranged? Well, first off, what you have to do is n factorial. So is that 6, 4, or 2? Which one represents this n up here? The 6, the 4, or the 2? Actually, none of them represent the n here. N is how many objects we have all together. So how many objects do we have all together? 12. Very good. Because 6, right? And 4, and 4 and 2 is 12. So we have 12 factorial. It's just how many ways I can jumble up those houses any way I want, right? Because it's 12 P12, right? I chose them all, so it's just 12 factorial. And so now what we have to do is decide, well, are some of them that I can't tell the difference? If I moved like this one-story house here and moved it over there and flip-flopped it with the other one, would I really be able to tell? No, because they don't have house numbers on them yet. So this 6, they are identical, so we would go 6 factorial, because that's how many of them that are identical. And again, if I just flopped some of the 2-story houses on my plan, would I really be able to tell that I made a change? Probably not. So this 4 then also goes down here. And then this 2 also goes down there, because I wouldn't really be able to tell. Now once again, you could type this into a calculator, but sometimes you can save yourself a lot of time. Because 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 times 6. And I'm going to stop there, if that's okay with you. Because at the bottom, I've got 6 times 5. That's coming from this one, right? So you agree basically 6 on down is gone, right? And then 4 factorial is 4 times 3 times 2 times 1. Well, here's a 12 and there's a 12, right? You with me on that? And here's another 2 factorial over there, so it's times 2 times 1. So really, it's 11 times 10 times 9 times 8 times 7 divided by 4, or you could get really tricky and just do, right? Just save yourself time, okay? But this is truly understanding, or with the 10, exactly, either way. So 11 times 10 times 9 times 2 times 7, okay? Or you could type that into a calculator. What's a lot harder on this one is how do you go to NPR for this one, that permutation button, and you really can't, okay? And so you type that in, and this number may be actually, I don't know, you might be surprised by this number. Not sure, maybe. What was that? 13,860? Surprised by that number? Seems kind of high, but if you just did 12 factorial, that's much higher, right? You're just jumbling them up. Okay, but we're saying we want to be able to tell that they have been changed. Is that very clear to you? The difference between this one and the other one? This is something I have to actually be able to tell that it changed. Okay. And the last one for today is a combination. So now we're just selecting our objects from a group of n without regard to order. Okay. So it doesn't matter. That doesn't give me another option. That's what that means. If I pick the same 3 people, it's the same 3 people whether I picked this person first, that person, then that person. I'm still getting the same 3 people. The order in which they get there does not matter. So it's NCR this time, and it has a slightly different. Would you expect this number to be larger or smaller than the permutation number? What was that? It was a yawn. Like smaller, okay? And that's why we're going to divide by an extra piece. So it's pretty much the exact same thing with another r factorial thrown in the denominator. That's basically another way of looking at it. It's taking out, some of those that would be repeats. And you will find this on your calculator in very much the same location as factorial and NPR. They are normally grouped together in some menu somewhere. Of course, or you could do it by hand. And I'll show you this one by hand if you want. So all right, we've got 3 people for an advisory committee from a group of 10. Okay. So this would be, do you see how order would not make a difference on this one compared to the other ones? Is that clear to everyone? Okay. So it's 10C3 is how you could write it. So in other words, 10C3 up there like that. So I'm looking at 10 factorial over 10 minus 3 factorial, and then another 3 factorial. Right? With me on that? Or in other words, this is just 7 factorial. So that 7 factorial cancels 7 on down on 10 factorial, right? So really this top just turns into 10 times 9 times 8 by the time I take care of, getting that out of there, right? And then I've got another, well, what is 3 factorial? You should be able to do that one in your head pretty quick. Just 6, right? Because it's 3 times 2 times 1. So you could do a lot of this, take a 3 out of there, take a 2 out of there. So apparently 120. Right? Hopefully that's the same thing that your calculator gave you, because that's what I got by hand. Ooh, that's a good 0. And I've given you this before, and I said it, I can't remember, was this in geometry that we had this, or advanced math maybe? Really, on the locks that you have on your lockers, according to mathematics, you have a locker permutation, not a locker combination. Because you can't just put your numbers in any order you feel like. The order in which you put them is important, right? Because it's not going to open just by putting 3 numbers in, right? Okay, so realized combination obviously has other definitions other than the mathematical one. Okay? Okay. But think of it that way. It's really a locker permutation when you're going through that, because you have to put it in a particular order. I can't just pick the 3 numbers. Okay? And the fact that you have to put them in order lowers the number that they have to actually put on that dial, right? Because it gives you more options if it's a permutation, right? Any questions? A lot thrown at you there. But hopefully a good chunk of it was review of some kind.